Electronics, class 12, practice test, specially designed for MDCAT, but the other universities which I have mentioned here, specifically for engineering universities, the entry tests which are conducted, that test can also help those students. The best way to watch this video and get maximum help out of this is whenever you see the question on the screen, just pause that video, think over it, write your answer on the sheet, and then let me explain and check whether the correct option, whether the what was in your mind, is that correct or not correct, and then we will try to understand. So that will be a very best way to get maximum help out of this video. Thank you. So moving towards the first portion of the questions which I have picked, the conceptual and theory based. Normally in the MDCAT version we call it recall based questions. Okay, so the first question is, the rectification is the process of converting AC into DC, DC into AC, low voltage into high voltage, and high current into low current. So the mechanism of pausing the video I have told you, so you do it by default at the when I read the each question. So here the correct option is the AC into DC. Okay, so the option A is the correct option. Furthermore, you also need to know about, because in the later MCQs we will also clear this, that there are two kind of rectification processes. One is a half wave, another is a full wave. Half wave is just like that if I have an input of this version, like I extend it, and the output in the half wave rectifier will be like this. Then half of the wave we have the break. Okay, so out of this whole chunk we have only converted this portion is off. Okay, and the same is for the full wave rectifier. If I just erase this, the full wave rectifier will be like this. Okay, but you must keep this thing in mind, that these are the pulsating output. Okay, later on we will come to know that what is this normal mode and the pulsating mode. The next question is that in a half wave rectifier, the diode conducts during, the options are both half cycles of AC input, only positive half cycle, only negative half cycle, and randomly. So in that case the option B is the correct one, only positive half cycle, because it makes the diode forward biased. Okay, fine. The next question is the purpose of the diode in rectification is to allow current in both directions, block current in both directions, allow current in one direction only, amplify the current. So in that case the main purpose of the rectification is to allow current in only one direction. So basically we need to convert the AC, which is a two-way, into one way. So only one direction is allowed. Okay, so this is the correct option. In the fourth question, in a full wave rectifier using a center tape transformer, two diodes conduct alternately. Both diodes conduct simultaneously. Only one diode is used. Output is purely DC. So in the fourth question, each diode conducts on alternating half cycles. Okay, so two diodes conduct alternately. Okay, so first of all, if we have two diodes, so for one cycle one diode works and then the other one is off. So that means that alternately they are working. So option A is the correct option. You may be thinking about that the output is a purely DC. Actually, this is not purely DC. It's a pulsating DC. Later on, with some additional circuitry, then we convert into a complete pure DC supply. Okay, question number 5 is ripple frequency in full wave rectification is. So here the options are the same as input frequency, half of input frequency, double of input frequency, and 0. So by ripple frequency, basically we mean that the frequency of AC which we are using is 50 Hertz. Basically, it refers to that 50 waves per second. But whenever we have the output, just like I am showing here, that for just one wave, we get 2 pulses. Okay, so 50 waves per second are replaced by 100 pulses per second. So actually the output frequency is the double of the input frequency. So double of input frequency is the correct option. The option C is the correct one. Next question is that depletion region in PN junction has free electrons only, has holes only, is free of mobile charge carriers, has both free electrons and holes. So here the correct option is that is free from mobile charge carriers, because the depletion means that the free charge carriers are vanished, and this carries only, I will write it here, positive and negative ions. Okay, they are not having any free mobile charge carriers, but they are actually positive and negative ions, so which are actually the bound charges. So the option C is the correct option. In question 7, in forward bias, the potential barrier of a PN junction increases, decreases, remains constant, becomes 0 instantly. So in forward bias, the potential barrier decreases, okay? Actually the potential barrier decreases, and reverse of it, let's say if we just have the forward bias, so if I change it with a reverse bias, then the potential barrier will increase, okay? So here the correct option is option B. In the next question, reverse biasing in PN junction causes increase in current, increase in depletion layer width, increase in increase in carrier concentration, decrease in resistance. So actually in this case, we have the correct option as that increase in depletion layer width, okay? And this also has another issue, that we have been informed that the option D is decrease in resistance. This is applicable actually in the case of forward bias, the option D, okay? In the reverse bias, we have the increase in resistance. So all the options must be clear. Increase in carrier concentration and increase in current is actually the output of the effect of the forward biased, but B is the correct option here in that case. Okay, in the 9th question, the typical forward voltage drop of a silicon diode is about 0.7 volt. Okay, so these are normally technical numerical values, and for germanium, if they are asking, so this is for germanium 0.3 volts. Okay, in reverse bias, the current through the diode is mainly due to majority charge carriers, minority charge carriers, both equally electrons from neutral atoms. So this is actually by the minority charge carriers. Okay, so this is actually a reverse current, and that is the option B is the correct one. Okay, then we come towards the some numerical approach. This may be also the part of your MDCAT or entry tests. In a half wave rectifier with input peak voltage 10 volts and diode drops 0.7 volt, then the peak output voltage is, so it will be actually 10 volt and 10 volt minus 0.7 volt, so that will be very simple. The option will be 9.3 volts. Okay, so this is the input, and you are just dropping this value 0.7, so 10 minus 0.7 we will get 9.3 3 volts. Okay, so the correct option is B. In question 12, for a full wave rectifier, the input frequency is 50 Hz. The output ripple frequency is, as we are talking about full wave, so in the previous question it was, we said that it is doubled, so it will be double frequency, so the options will be, the correct option will be 100 Hz because the input is 50 Hz. Okay. And for the RMS value of the output voltage for a half wave rectifier, Vm is equal to 10 volt, is approximately. So keeping in view that we have the RMS value. So RMS value is actually a concept which you have learned in the AC circuits chapter 15, and that is actually Vrms is equal to 0.707 multiplied by Vm. Vm is actually the peak value. So if I just put this peak value 10 multiplied by 0.707, so it will become 7.07. Okay, just let me check. The RMS value of the output voltage for a half wave rectifier is approximately, yes, the correct option is option C. Okay, fine. The average DC value of the output voltage for a full wave rectifier with 10 volt is. So for finding the average, we just write this V average DC, which is equal to 2 Vm divided by pi. This is the equation. And putting all these values, the value of Vm, which is 10, you will get 6.36 volts. Okay, so you just put the value of this 10. So 2 tens are 20. 20 divided by 3.14. So you will get 6.36. So almost, if you are not going through any detailed calculation with some rounding of value or with some suggestion or just guess, you can get the option C is the correct option. The rectification efficiency of an ideal full wave rectifier is approximately, this is talking, they are talking about the full wave rectifier, and its frequency is 81.2%. So this should be remembered to you. Sometimes these kind of numerical values can be given, which are normally not available in the KP textbook, but on the other textbooks these are available. So this should be clear to the in the mind of students. Okay. The next question is in a reverse biased PN junction, if the reverse voltage is doubled, the reverse current approximately doubles, halves, remains almost constant, becomes zero. So as it is almost independent of that reverse voltage, so this is the option C is the correct. It remains almost constant. The next question is for silicon diode, if forward current is 10 milliampere at 0.7 volt, and then at 0.8 volt the current approximately becomes. So for clarifying this numerical without any solution, we need to know that there is a graph between. This is the graph in which we have the exponential increase. So the maximum result will be 80 milliampere, which will be the correct option, option D, because it's just like an exponential increase. The ripple factor for full wave rectifier is approximately 0.482 for full wave rectifier. Okay, so that is the option B. And in question number 19, the peak inverse voltage of a diode in a center taped full wave rectifier is, options are Vm, 2 Vm, Vm by 2 and 4 Vm. So it is actually each diode must withstand 2 Vm when reverse biased. Okay, so this is the correct option. And the final question here is, if input AC voltage is 20 volt or a Vrms, what is the DC output voltage of a half wave rectifier? Ignore diode drop. So for finding this value, we use this equation 0.318, which is the efficiency factor, into Vm, and Vm will be calculated by multiplying the RMS value into 1.414, which will be, the whole product will be equal to 6.36 volts. So overall, these are the numerical and conceptual based questions. So kindly share with your friends for maximum help to the students. Thank you.